Using Excel for two-way analysis of variance. This video uses example 1 from section 12-3 titled Performance IQ Scores. You can use either Excel's Data Analysis add-in or the Excel Stat add-in for two-way analysis of variance. We will begin with the procedure using Excel Stat, followed by the procedure for using Excel's Data Analysis add-in. When using Excel Stat for two-way analysis of variance, ensure that all of the sample data are stacked in a single column and the corresponding category names for each data value are stacked in two other separate columns. One column for the row names and the other column for the column names. In this example, we entered the data from table 12-3 in columns A, B, and C. Column A contains the blood-lead level category for each data value. Column B contains the sex category for each data value. And column C contains the sample data values. Click on the Excel Stat tab in the ribbon, then click on the Modeling Data button and select ANOVA from the drop-down menu. You should now see the ANOVA dialog box. First, enter the range of sample values in the Y-dependent variables box. In this example, we enter C1 through C31. Next, enter the range of cells that contains all of the row and column names in the X explanatory variables box. In this example, we enter A1 through B31. Also ensure that the qualitative box is checked. Select Sheet to display the results on a new worksheet, and if a variable label is included in the data range, check the Variable Labels box. In this example, we check this box. Click the Options tab and confirm the Interactions Level box is checked and set to 2. Click the Outputs tab and check the box labeled Type 123 SS. Click OK. In the Factors and Interactions dialog box, check all three boxes. Click OK, and the ANOVA results will be displayed as shown. The F statistic is labeled F, and the p-value is labeled PR greater than F. In this example, the label of lead times sex denotes the interaction effect. We begin by testing the null hypothesis that there is no interaction between the two factors. In this example, we get the F test statistic of 0.431 and the corresponding p-value of 0.655. Because the p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis of no interaction between the two factors. It does not appear that the performance IQ scores are affected by an interaction between sex and blood-lead level. There does not appear to be an interaction effect. For the row factor of sex, we find the test statistic of F equals 0.072 and the corresponding p-value of 0.791. Because the p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis of no effects from sex. That is, performance IQ scores do not appear to be affected by the sex of the subject. For the column factor, blood-lead level, we find the test statistic of F equals 0.099 and corresponding p-value of 0.906. Because the p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis of no effects from lead level. Performance IQ scores do not appear to be affected by whether the lead exposure is low, medium, or high. In summary, based on the results, we conclude that performance IQ scores do not appear to be affected by sex or blood-lead level. When using Excel's Data Analysis add-in, for two-way tables with more than one entry per cell, entries from the same cell must be listed down a column, not across a row. Enter the labels corresponding to each data value in the first column. In this example, we have entered the data from table 12-3 in columns A, B, C, and D. Column A contains the sex category for each data value. Column B contains the data values for the low blood lead level group. Column C contains the data values for the medium blood lead level group, and column D contains the data values for the high blood lead level group. Click on the Data tab in the ribbon, then click on Data Analysis. If Data Analysis is not available, you must install the Analysis Toolpak add-in. You should now see the Data Analysis dialog box. Click on ANOVA 2-Factor with Replication under Analysis Tools, and then click OK. Note, if you have a two-way table with exactly one entry per cell, at this point in the procedure, you should select ANOVA 2-Factor without replication. In this example, we select ANOVA 2-Factor with replication, and we now see the ANOVA 2-Factor with replication dialog box. Click on the Input Range box and enter the range containing the sample data values. In this example, we enter A1 through D11. In rows per sample, enter the number of values in each cell. In this example, we enter 5. Under Output Options, select New Worksheet Ply. Click OK, and the ANOVA results will be displayed as shown. The row labeled Sample corresponds to the row variable, which is sex in this example. The row labeled Columns corresponds to the column variable, which in this example is blood lead level. The F statistic is labeled F, and the p-value is labeled p-value.